Viewers, you are watching Mathematics channel number Collage. In this question, we have to find orthogonal trajectories of the family of curves in the polar form where a is an arbitrary constant. As usual, we start with finding derivative of the given polar form r equals a theta. For that, we have to take logs on both sides. So taking logs of r equals a theta, we write ln r equals ln a plus ln theta, and now we differentiate this with respect to theta. 1 upon r dr by d theta equals derivative of log a is 0, derivative of log theta 1 by theta. Here the arbitrary constant a gets eliminated in the first derivative itself. Next, we have to replace dr by d theta by minus r square d theta by dr. That gives 1 by r into minus r square d theta by dr equals 1 by theta. Cancelling 1 r, we get minus r d theta by dr equals 1 by theta, which is the differential equation of the orthogonal trajectories. Separating the variables, dr by r equals minus theta d theta. Integrating, we get ln r equals minus theta square by 2 ln c, the constant of integration. Ln r upon c equals minus theta square upon 2, or r upon c equals e power minus theta square upon 2, or simply r equals c e power minus theta square upon 2. And this is equation of family of orthogonal trajectories of r equals a theta. In this example, we have to find orthogonal trajectories of a family of curves in the polar form r equals a 1 plus cos theta, where a is an arbitrary constant. As usual, we will start by finding the derivative of given polar equation r equals a into 1 plus cos theta, taking logs on both sides. Ln r equals ln a plus ln 1 plus cos theta. Now we will differentiate with respect to theta. 1 by r dr by d theta equals 0 plus 1 upon 1 plus cos theta into minus sin theta. For orthogonal trajectories, we replace dr by d theta by minus r square d theta by dr. That gives 1 by r into minus r square d theta by dr equals minus sin theta upon 1 plus cos theta. Cancelling 1 r and rearranging the terms, or separating the variables, 1 plus cos theta upon sin theta d theta equals dr by r, which is the differential equation of the orthogonal trajectories. Before we integrate, we write 1 plus cos theta as 2 cos square theta by 2 upon sin theta as 2 sin theta by 2 cos theta by 2 d theta equals dr by r. Next, we cancel these 2 and 1 cos theta by 2 and integrate, which is integration cos theta by 2 upon sin theta by 2. Since derivative of the denominator sin theta by 2 is in the numerator cos theta by 2, integration will be ln sin theta by 2 upon half, which is 2, equals ln r minus ln c dash, constant of integration, which is ln r equals ln c dash plus ln sin theta by 2 whole square. This will be ln r equals ln c dash sin square theta by 2. R equals c dash sin square theta by 2. C dash for sin square theta by 2, we write 1 minus cos theta upon 2. R equals c into 1 minus cos theta, where c dash upon 2 is C. And this is the orthogonal trajectories of this family of curves. We have to find orthogonal trajectories of the family of curves 2a upon r equals 1 plus cos theta, where a is an arbitrary constant. To start with, we will take logs on both sides of the given equation. It will be ln 2a minus ln r equals ln 1 plus cos theta. Now differentiate with respect to theta. Derivative of ln 2a 0 minus 1 by r dr by d theta equals 1 by 1 plus cos theta into minus sin theta. 1 by r dr by d theta equals, for sin theta we will write 2 sin theta by 2 cos theta by 2 upon, for 1 plus cos theta we write 2 cos square theta by 2. Cancelling 2 and 1 cos theta by 2, we get tan theta by 2. Now for orthogonal trajectories, we will replace this dr by d theta by minus r square d theta by dr and write 1 by r into minus r square d theta by dr equals tan theta by 2. Cancelling 1 r and rearranging the terms and separating the variables, we write dr by r equals minus cot theta by 2 d theta, which is the differential equation of orthogonal trajectories. Further integrating, we get ln r minus ln sin theta by 2 multiplied by 2 here plus ln c, constant of integration. Ln r equals ln c upon sin square theta by 2, or simply r equals c upon sin square theta by 2. R equals c upon, in place of sin square theta by 2, we can put 1 minus cos theta upon 2, which goes in the numerator here. So r equals 2c upon 1 minus cos theta is the family of orthogonal trajectories of this family of curves 2a upon r equals 1 plus cos theta. Viewers, if you like this video, please like, share and subscribe this channel, Number Collage. See you in the next video. Until then, keep watching Number Collage. Thank you.